Good afternoon, everybody. I'm starting, and I will take over in the middle of the presentation, and I will conclude rapidly. So, you have been hearing a lot of a few acronyms like DDMS and Skywise and digital during the day, so we'll try to go a bit deeper and to answer your question at the end. So, Airbus, we started 4 years ago, basically, our digital journey. And there is no textbook on digital transformation. So we muddled through and tried to get our things right. So like many other companies, we explored these 9 technologies. We scouted for these technologies. Most of them have been originating from the B2C business. And the question was, can we apply it? How do we apply it to industrial systems like aerospace and aviation? As you could see, there's another message on that slide. There are different stages from experimentation to industrialization. You will hear about a lot of companies doing proof of concept, MVP, minimum viable products. There is a real challenge from moving from experimentation at little scale to embedding these technologies into industrial processes like aviation. So this is a key message, and that's why you see different maturity levels according to the different capabilities that we have been insourcing into Airbus. Everybody's talking about the technologies, but this is what we want. What we want is outcomes. We want use cases. How can it be applied to Airbus and to aviation? So just one example, because everybody is talking about artificial intelligence. In itself, it's interesting. But what does it mean for us? As you could see, we have identified the capabilities in artificial intelligence and machine learning that provide value to us, and we are in the way of industrializing them at scale. You can see a few examples about especially turnaround time optimization, so very concrete use cases where algorithms about image recognition can tell you what the vehicles around the aircraft are doing, so when the aircraft is ready for departure. There are many other applications, and these ones are only the headlines, but they are very specific to the use cases in Airbus. Other outcomes, one we call airline science. It's looking with all the computing power that is available today on all the archive that we can collect of flights for one route, for one type of aircraft in one configuration, and same thing for the engines. The idea is not to think anymore about averages of performance on a standard route. It's trying to optimize every parameter of the aircraft on a single day for a single route. And this is playing billions of combinations. It's processing years of routes, and you have an example here of a route, and the idea is to provide to operations the best scenario possible for configuring the aircraft and taking the most appropriate route, the appropriate flight profile, and the appropriate real-time actions from the crew. So these are typically outcomes and capabilities that have been industrialized and that we use internally in our commercial campaigns or in also the route optimization for our customers. Another outcome, which is not visible, but trying to give you fact points, we have become a telecom operator. It's not obvious, and it's not our core business, but you have heard about FOMAX. I think you've seen the box outside. FOMAX is connecting the aircraft to push data on the ground. And to push data on the ground in a global aviation, you have to become a virtual operator worldwide. So we had to develop capabilities. As usual, we didn't develop it alone. We developed it with partners. But this is a new capability and a new deliverable that we are providing directly or indirectly to the customers. Sorry, I'll go one step back because you will read the slide otherwise. These are just a few examples. I just wanted to give you outcomes and not capabilities and technologies or ideas. You've seen many examples there. You've seen the cabin equipped with sensors. Mike has been talking about IoT deployment in the factories, in the manufacturing. We have virtual reality, 3D printing, so I could list a number of technologies which are less visible, probably, and less transversal than Skywise and DDMS. But what we discovered by applying these capabilities to the use cases in Airbus is that we learned a few lessons, a few takeaways. First one is one I touched upon. It's very difficult to industrialize. Very difficult to move at scale. Many people get stuck on the left part of the wheel. You don't have to look at all the details. I can explain later. But from a successful MVP at a small scale to embedding the technology in our core, very stable processes, it takes a real methodology and it takes a real team, because this involves not only the business and the change in processes, but also security and ways of working. Second thing we learned is that many people are talking about artificial intelligence, blockchain, whatever. It's all about data. So until you have answered the question, where is my data, what is the data, which is important, how do I manage my data, how do I make it transversal rather than locked into silos, you have no foundation for any technology, because data is powering all the other domains. So I'm very happy to talk about artificial intelligence and the rest, and IoTs, but until in a company like Airbus, industrial at scale, you have mastered the access to data, you have not any foundation to grow further. The third takeaway is it's linked also to data and to industrialization. You have to put in place a certain number of foundations that allow you to free the data and also to industrialize. First one is IM. Sorry for acronyms. IM is information management, so IT, if you want. All the IT landscape is, as you know very well, completely transforming. We have new skills, we have new capabilities, we have cloud, we have artificial intelligence to manage the system, which are becoming more and more complex. So the transformation of the information management inside industrial companies is becoming essential. It's very important because in our companies, as you well know, aerospace engineering is and remains and was the core capability. Industrial, manufacturing engineering, manufacturing, supply was also a core capability. IN was a very far away, remote, I would say, support function. As you could see today, it's becoming blended in everything we do, from design to manufacturing to services. So we have to completely transform the profile and the proeminence of our IM departments to the service of business. The second thing which is missing in most of the industrial companies is data governance. When you ask simple questions, who is owning that data? Who is giving rights to people to access that data? What level of classification for this data? Can a supplier access it? Can we share it with the airlines? All that is about data governance. It's not only about regulation, it's about how do you use the data? And who is the authorizer? And how do you monitor? So all that has to be put in place. It doesn't exist naturally in industrial companies. It's a huge, huge challenge. But at the size of Airbus, to put in place such not only the policy, but the execution of the policy takes a tremendous effort and lots of tooling and education. Just a data point on data governance, we have more than 200 people today dealing with data governance into the company. We're basically a handful 3 years ago. So it's not 200 people full-time, but we have 20 full-time people and 180 part-time people in the business who are data custodians or data officers, releasing, authorizing, monitoring what we do with the data. Of course, you hear that every day. Cybersecurity is paramount. The more we centralize data, the more we share data, the more we have people leveraging data to create value, the more we have to guarantee cyber resilience and cyber protection of the data. It's a challenge because, as you well know with your own personal applications, it's a trade-off between perfect security and collaborative work. So there are things you need to put in place to organize these trade-offs and to monitor these trade-offs in a very responsible manner, especially when you're dealing with data from third parties, which can be airlines, employees, suppliers. So I just wanted to give these highlights, so examples of use cases, foundations and technical capabilities to arrive to this slide. This slide is probably summarizing what we have been doing in the last 2 to 3 years, building digital continuity. I was saying that data is the core of this transformation, of this revolution, and that's how we came up with creating Skywise and then DDMS. So to give you a picture, we have been bridging all the systems in the different silos in the organization into a data lake that we have been filling use case after use case with a proper security and data governance. And this data lake that we used initially internally, but now with customers and with suppliers, is basically rebuilding the digital image, digital footprint, the digital shadow, as we put on the slide, of the aircraft. When we are not digital native, which means when you don't have the perfect end-to-end digital model into the system, this is what you have to do. You rebuild it aircraft by aircraft through every data point that the aircraft has been touching, from design to manufacturing, to in-service, and to retirement. That's what we store, basically, in Skywise. And this is paving the way, because it's in place now. This is paving the way to what Alain will develop and is the complementary in the future, which is native digital continuity with a digital twin for the next generation of aircraft. As you can see, it's not the same time horizon. Digital shadow is available today at a cost which is relatively minimal because there are no huge investment in systems. And DDMS and native digital continuity will come with the next generations and with a roadmap which is bridging today with the next generation. One doesn't exclude the other. It's not because we will have a better digital twin for the next generation that we will not have to manage in the future legacy programs, the interface with the suppliers, the interface with the airlines, the interface with the regulators, with the MRO. So heterogeneity of data will remain. So it will be better structured horizontally and continuously in the next systems, but still we will have to find a way to build these bridges, and Skywise will continue to live next to DDMS. So I developed a bit on Skywise. You have understood it's only one initiative, but Skywise and DDMS are really transformational for Airbus and we believe for the aviation industry, because they are truly horizontal and they are not only embracing Airbus, they are embracing the whole industry. So we started in Le Bourget 2 years ago, a bit less than 2 years ago, with 4 early adopters. A few of you were there. We were not totally convinced of where we would end up. And we had grown confidence with internal Airbus application because we had applied these data lake technologies and applications to our internal Airbus issues. We mentioned at that time what we did on 350 non-quality, 350 ramp-up. We have many examples of what it brought internally. So we extended it to the customers because the aircraft, of course, doesn't end at the gates of the factories. Where we are today, which gives you also an impression of the speed at which these transformations are running. In 2 years, we have grown from 4 early adopter airlines to 70 plus airlines, and from basically a few hundred aircraft to more than 6,000 aircraft, which are beaming data into the platform. And including the internal users, we have more than 10,000 users monthly on Skywise. I think it's a very important message to see at which speed an industry that we thought would be pretty late adopter into digital technologies can be leading or can be disrupted if we don't take the measure of the revolution which is happening. This is another view by number of users that just tell you about the acceleration. That's mixing the users from the airlines, the users from the suppliers, and the users from internal Airbus projects.
Hi everybody, I'm Gary. I'm Director of Operations Transformation at EasyJet. Like all things, the journey to Skywise started with leadership, with imagination, with a vision.
Skywise has helped us to solve our vision of predicting maintenance with large aircraft sensor data. In order to avoid disruption, we wanted to get ahead and understand what faults could be coming on the fleet so that we can avoid them occurring and the disruption to our passengers and crew. Since we started using Skywise, we've seen benefits across our maintenance operations. We've removed about 120 parts with a very low rate of no fault found. So we're avoiding issues on the fleet before they occur. This is stopping AOGs, delays, or MEL conflicts. So it's having a real positive effect on our operation.
Hi, I'm Travis Yost. I'm Director of Planning and Analytics at Allegiant Air. I've been at Allegiant Air for 4 years, and we've been on the Skywise platform for 2 years. The biggest area of opportunity that we've realized at the company has been in relation to regular operations. We've seen both on the predictive and prognostic side that Skywise has been very accurate in terms of alerting strategies for Allegiant Air, and consequently, as a result of those alerting strategies, helping us reduce delays, cancellations, and AOG scenarios. We are saving no less than 1 aircraft out of service per day, largely based on predictive alerting on our A320 family aircraft, but also in relation to expediency and heightened accuracy during the troubleshooting process in reactive AOG scenarios. Allegiant has basically went full throttle into Skywise, and we have decided that we would envelope everything within our master information system, along with all of the tools that Airbus had already provided us, into the Skywise platform. So at Allegiant, it is a full push to put everything on the maintenance and operations side in the Skywise platform.
The main value that we have seen in Skywise, I will say that is mostly at the beginning, where we automate a lot of KPIs and a lot of processes. And we make a more standardized way on how we calculate the KPIs, and we get a single source of truth through the platform. We see some value in the preventive app that we have developed, and we have an improvement on 10% of the delays that we usually used to handle.
So that was a little surprise. I don't know, it ends abruptly, but this is the voice from the customers on the airline side. The 70 plus airlines that are currently on the platform. For those who have not yet completely understood what is Skywise, you can see it as an aerospace app store, basically. So there's a data lake where we have data inside, where the airlines connect their data, and they are developing themselves, or we are developing, like Remy was saying this morning with the Airbus services, we are developing applications, or they are developing applications to resolve specific problems. So one thing which is interesting is that we are providing basically the tool for their own digital transformation. They just have to provide the data, plug the pipelines, and then they can start working on real use cases about turnaround time of their aircraft, on-ground operations, in the air operations. It's an open platform for airlines. Airlines are openly sharing data, provided that they see value. And we managed to resolve, I'm sure you have questions about how do you share data, how do you manage this boundary. I can tell you it was much easier, and you could see the speed than forecasted because of the value potential we could demonstrate to airlines and to suppliers. What you've seen also, don't misrepresent, is only the airline side. You should not forget that we have the same applications internally in Airbus and with the suppliers and the supply chain. That's exactly what is on the graph now. This is where we started, Airbus internal, Then we moved naturally to our customers and to the aircraft in operations, and then we moved back to suppliers because the performance of our industrial system or the performance of the aircraft in operation is depending on the people who are providing the systems. But this is not the end of the journey. So we have not finished with suppliers and airlines, but we know already there are many other contributors of data to the aviation industry, and all these people play a role into the performance of the aircraft on the ground or in the air or economically. Airports, lessors, MRO, authorities, of course, all with a different prism, but they're all interested in operational data, manufacturing data, configuration data, engineering data. And they all have use cases. Think of it again like an app store. They all have their own application to build, to answer their own questions, and to change their own processes to create value. And the last wave will, as you could see in the marketplace, will include more sensors, not about the passengers as privacy and behaviors. It's not our business. We like passengers' movements and configuration of the cabins to, again, increase either the performance of the aircraft, the turnaround time, or the comfort of the passengers and of the customers. Third-party developers, which is the last part there, when we want to build an open ecosystem like this one, where people share and create common value, we want to have third-party developers. So Airbus is providing a certain number of solutions. Airlines or suppliers are developing with their own teams or suppliers applications on the platform. And we welcome, and we are developing currently the SDKs and the APIs, the interfaces, for any type of developer to come and develop applications based on our data governance, but with access to some part of the data. And these applications can be for the general public or could be for airline or industry specific. Creating an ecosystem around Skywise is clearly the next priority for us, so that this endeavor really transforms into an industry-wide platform. So I will hand over. I think you understood the bottom. That was the main speech I did on the digital shadow and Skywise and reconstructing this layer of digital continuity, which is resolving key problems for Airbus and for the industry. And I will hand over to Alain, who will dig deeper into the native digital continuity brought by DDNS. Thanks.
Thanks. So I will present what is digital design, manufacturing, and services. I will try not to use too many acronyms because we are really always focusing on that. But first, to set the scene, what are we looking for? What are we trying to deliver? Clearly, we have three words. First, customer. All what we are doing, and it was said this morning by Philippe, is for the customer. So we need really to understand what will create value, what makes value for the customer, and all what we are going to develop, and that I will explain later on, is with this strong focus. I will jump on the third one, which is societal expectation and the sustainability. We spoke a lot about that also this morning, and it's really a key point, and it's a key point that we are addressing in the project. That means we cannot deliver an aircraft without considering and all the services around the sustainability. And of course the competitiveness, because we need to be competitive if we want to provide the service and the product which is expected by our customers. So where are we today? And you saw it in the presentation also this morning. We are moving in a production which was some years ago or 10 years ago with quite low, what we call low production rate. I mean, we are delivering 10, 20 aircraft a month. And it was considered already as a lot of aircraft. Now we are targeting, and it was said this morning, a little bit more than 60, and perhaps one day other value. So that means we are moving in what we should call for aeronautic industry mass production. So versus automotive, it's perhaps a small volume, but for a project and a product like an aircraft, it's really mass production. So if we want to make it happen for the next generation, that means we need to make a breakthrough. We need to ensure that when we will deliver the first aircraft, as it was said also, we are able to ramp up very, very rapidly The product that we are delivering is completely mature. That means we have validated everything before we are delivering a single aircraft to a customer. And really, we improve the value that we are generating for our customers. So if we look a little bit where we stand, many aircraft in the backlog, so that means there is a strong need of aircraft, more than 7,000, increasing demand on the aircraft, and increasing rate. We quoted this morning. What are the drivers? We need to be on cost, we need to be on time when we are delivering, we need to deliver with the right standard of quality, we need to embark all our partners and all the supply chain, because what we are going to deliver will be just the result of the combination of the complete system. So we need to work on accelerating the ramp-up, shortening the time to develop a product and an industrial system, so time to market. Improve the maturity, we need the maturity from day one. And clearly to develop new services. I mean, we can develop value for the customer and for us. And so really service development is the key point. It was raised by Remy this morning. So digital design, manufacturing and services is really working, and I will detail it a little bit more now. It's not a tool project. It's really something which is a major transformation for us, because you will see we are addressing at the same time some of the concepts in the way we are designing our product. It's clearly impacting the way we are designing the industrial system, and it was said by Mike. We work on the processes, we work on the tool, and obviously we work on the skill, on the training, on the transformation of our teams. So I will spend some time on this slide because it's a key one. So I will start by the left side to explain the way we are going to work tomorrow and the way the process will be run. So clearly we are going to revisit the way we design and operate the product, ensuring product, industrial system, support and services are tackling at the same time. So I will start by the left side. Usually when we are doing a product, we are working a lot on simulation, on virtual model of the product. It's something which is quite well developed since years in the aeronautic industry. It's a little bit more weak on the industrial system, and on support and services there is still some room, as Mark explained, to work on it. So what we are willing to do is to work first in a single architecture of data and of know-how. It's what is called the digital backbone. What does it mean? To be very specific, is that in fact each data will be captured only once. We'll have the chain to ensure that we have the truth in the data, and this will be supported by a single platform, which means that if at the time you change something, I will take on the aircraft, you are able to assess in real time what does it mean for your industrial system, what does it mean for the support, what does it mean for the services. So you have something which is completely integrated because we have only one architecture of data and something which is flowing with a single channel for the data. To make it happen, we'll work with the concept and we'll reinforce the concept of what we call co-development, which means that we need to develop also based on virtual model, not only the aircraft itself, but the industrial system, Mike quoted a little bit previously, and all what is support and services. I mean, working with this model, which are called twins, virtual twins, we'll be able to find what is the best solution by combining scenario, by making a modification on the industrial system and understanding what does it mean on the aircraft and its performance, or on the way we are going to operate the product. So it's really a loop where we are going to find the best solution versus the top program requirements. We get an objective and we are able really to assess, to compare scenario and to find the best solution. Important when we speak about the industrial system, it's a complete industrial system, it's a complete chain, which means it's a chain with Airbus, what we are doing internally, but it's also what we are doing with our partners. So that means it's really an end-to-end view. So from that, the team in this so-called co-development approach is going to develop the best-in-class solution. Best-in-class meaning a product with the highest level of performance, a product where we can ramp up, as said this morning by Philippe, very, very rapidly, a product where through simulation we have validated the maturity and the quality, and also the capability to simulate the way the aircraft will be operated and the type of service we could develop which are bringing value for the customers. And so we move on the third column, which is what we call the physical execution. That means when we have done all these studies, when we have found the best solution, now we have to execute and operate. That means we will manufacture the aircraft as it has been defined, based on the industrial system that we have designed, and thanks to the models that we have generated, we know exactly what we have to master. That means thanks to the twin, we know that this parameter is a key one, and we need to master this parameter, whatever this action is done in the partner facilities, or this action is done in an Airbus plant. So really we are able to master the food chain, and the same the way we are operating the product and supporting the product. What is key is, thanks to the input and the fact that we have defined this key parameter, we are able to apply what are the small circles, which are performance optimization. That means locally, we are able to compare, are we really with the right value of data? That means we said to be at the top, you need to get a value of X. Are we at X, or Y, or Z? And which means that you can react locally to parameterize your system and to correct when you see that you have a small deviation. The other point which is quite important is that this data will be captured, and it's a strong link with what Mark has explained with Skywise, to feedback the digital twins for two reasons. The first one is really to reassess in real time the performance and all what we have simulated. And the second reason, which is the main one, is to be able, by simulation, to anticipate the next step. So that means if I have a rate, let's say 10, and I know that in 3 months, 6 months, I have to go to rate 20, I can capture my data at the rate 10, simulate what does it mean at rate 20, and like this, which is the arrow on the top, I can anticipate, identify when I have to apply any modification, if I have to apply any modification, and thanks to the 3 digital twins, the product, the industrial system, the support and service, I can identify when I have to apply this modification to generate no pollution at all on the operations. So I mean, it's really a complete system that we are working, combining virtual development, combining data, and combining physical execution of the product. So to make it happen, we've organized this transformation over 5 pillars. And on this slide, I will speak only about the last one, the one I will describe in the next slide, which is transformation and competencies. Clearly, to make this transformation and all what is digital, digital is a way to make the things, to accelerate, to create value. But at the end of the day, what is creating the value is a team, is the people we have on board, either the one which are in Airbus or the one with our partners. So clearly, we have a strong focus on what we have called transformation and competencies. Because we need to transform, it will be new processes, new way of working. We need to get new skills, and so that means we need to train and to embark all the ecosystem to be ready for this type of transformation. So transformation and competence is really one of the key points we are addressing through the project Digital Design, Manufacturing and Services. Now we will go to the 4 other bricks. The first one being product lines. One of the objectives we have is to work on the maturity, to reuse also solution, that means to leave a little bit the solution which is a very ad hoc solution where each time we modify a small requirement, we modify completely the solution to something where we are able to combine modules and predefined solution, what we call predefined solution. So this is something that we are addressing through the stream, we call it a stream, which is called product line. So you can see on the image that we are looking, can we reuse some parts, some elements of one aircraft over a family? It was one of your questions this morning. Are we able to define a module which should be used, for example, on an A320 and an A220? So this is really what is behind the product line concept. Co-development and integration is a point that I raised in my previous slide, is really working together. That means we have not to define a product, then assess what is the system to industrialize research challenge on the rate, and afterwards to optimize the way we can operate or service the aircraft. It's really everything must be done at the same time to find the best solution. The best solution encompassing the product, the industrial system, the support and the services. And it's what we call co-development and integration, which means that we'll change our process and we'll change the way we are collaborating with our partners to make it much more efficient. Third point, this one is quite obvious, is modeling and simulation. If we want to make this step change, we need really to work hard on the capability to make virtual model, to simulate, and to be sure that the maturity and the accuracy of the model we are developing is really high. And it's why we are already implementing, and you saw it in the previous presentation, on some parts of existing programs, of legacy programs, really to calibrate, to demonstrate the added value, and to ease all the challenge we have to face. So modeling and simulation is something which is really important because it's not only modeling and simulation for product, again, it's industrial system, end-to-end, support, and services. The platform and the fact that we are able to have a single source of data over the full life cycle, that means whatever we are working on the backbone tool, the usual tools which are used for design, the one which are used, as shown by Mike, for manufacturing execution system. In fact, at the end of the day, we need to have the continuity, whatever is the tool, we call it like that. So we are developing a platform and ensuring that we have an interoperability in this platform to ensure the continuity of the data and the continuity of the know-how. If somebody changes the data, everybody knows that the data has been changed, and we are able to assess in real time what is the impact of this modification by simulation. So we are already starting to apply, so we took some few examples. All this improvement and all these goodies, I will say, and we have some demonstrators. So we have one which is on the nacelle, what we have called NIS, Nacelle Innovative Solution, where we are developing a new nacelle working really at the same time on all these, I would say, 3 pillars. The product itself, its industrial system, all the way we are manufacturing and integrating the nacelle, and also the way we are going to support and bring value and services for the nacelle. So it's focused on the A320neo Pratt & Whitney, and we are targeting an entry into service around early 2022. So really it's already well advanced, and we are also all the bricks. We have put only one example that we are implementing on the existing program. The other point on which we are bringing value, you saw some image in the presentation of Mike, and I think also of Philippe this morning. And as you can see, we are also working on simulation to really optimize the way our industrial system, this is a fan, is operating to be able to challenge and assess different scenarios. I mean, again, the target being we need to prepare the next step of evolution of the rate. We need to see how we can improve our performance. And so we do it by simulation, making, I would say, iteration between the real world that you see there and the model that you have seen in the presentation. So it's really something which is key, because by combining the two, you can make a massive step in the way you are setting your system, which means that when you are going to invest all these physical assets, in fact, you have already a very strong definition and a very strong validation of this overall system. So this is in a few words what we are targeting in the project Digital Design, Manufacturing and Services. And I will hand over to Mark.
Thanks, Alan. So I hope at this stage that you have understood that we are dealing more than with tools and systems, and it's really a complete change of the company. I just want to take one step back. And in fact, in a nutshell, what are we trying to do? We are, through the different examples that we've mentioned, from SkyWest to DDMS, from this digital continuity, we want Airbus to become a data-driven company. We want data-driven decisions, to make it very simple. We want our people to have the right information at the right level, at the right time. And we want, as was mentioned, the context, and we want a single point of truth. We don't want anymore to have different versions of the data through the different transformations. It's a big ambition at the scale of Airbus, you can imagine. But this is truly what we are trying to build. What we are, or we're a bit further than that now, but we know we have lots of data. We have lots of data into Airbus, we have immense data in the supply chain and in the operation of the aircraft. What we are building basically, very conceptually, is the transformation matrix, basically. We are building the capabilities and the structures to make sure that this data can be put and made available on the right, to the right people in the right time. And as you can see, it runs much deeper than tools and systems. It's about cultures, it's about ways of working, it's about organizations, it's about people, of course. We need a new skill, we need to retrain some of our people, we need to change our core processes, even in aerospace, like was mentioned for DDMS, because there is no value creation until somebody changes something into our core processes. Data is nice, but applying data requires that you change ways of working into aerospace processes. And of course, you need to put in place foundations and technology bricks and infrastructure. So, we talked these last years a lot about a program-driven company. The good news is that a program-driven company is crossing all the silos, the vertical silos, the functional silos, and the data approach, the data-driven company is going exactly the same way. It's aligning ourselves across silos on the program, and in the end, on the performance of the product and the customer. So it's a very, very important transformation. And again, trying to wrap it up, that would be the last slide, taking one step back and reflecting where we started in aerospace. There are several myths and realities that we discovered along the way about digital and aviation. The first one was aviation will be different. I mean, digital is about, it's nice about Google, it's nice about Facebook, it's nice about B2C, but honestly, for industry and serious industries like aviation, we don't see really, and there will be no impact. That was the main fault probably 3 to 5 years ago. Of course, I think at that stage, I hope you're convinced, and there are many examples also outside of Airbus, that things are changing really quickly, including in aviation. It can be applied. Each time we have looked at this digital discontinuity problem, we have looked at 2-digit improvements. In every project we've been doing, you have seen some testimonies of the airlines, we have exactly the same metrics on the supplier side, we have the same metrics inside out. If you map that at the scale of an industry which is 800 billion turnover, we are talking of several tens of billions of inefficiencies or opportunities that will be brought about by digital initiatives across aerospace. And that's an answer also to the question I raised before. Why do people want to cooperate? Because people have understood that there is more value to share than to keep data and ownership for themselves. That's what we have demonstrated, I believe, with airlines and suppliers. And that's what we will demonstrate tomorrow with DDMS. Another myth is that the business model we have is pretty stable. We know it perfectly for 50 years. Don't forget that we are talking probably about the most complex product of the Industrial Revolution. So this is a well-established industry, and we will not be challenged easily. First, I think it's very wrong, and we should not believe that. I show you the acceleration we have on Skywise. Think about what a pure digital native could do in an industry like that, just taking the axis of data. Disintermediation in this industry also is possible. And if we would not have done Skywise, somebody else could have done it. So let's be very careful about established business model, even in our aerospace industry. We can see also with Skywise that boundaries are changing. Who would have thought 3 years ago, 5 years ago, that it was possible to exchange data with airlines, that it was possible for Skywise to host Boeing aircraft? So, again, the business models are changing at speed. And it's not about selling. I will not enter into detail about the business model for Skywise, but it involves lots of complexity and some are close to the platform economy of Amazon rather than purely selling services or charging services to the airline. On the slide, there's something else which is mentioned. We are, through the program of DDMS, through what we see in the Skywise improvements in operation for the aircraft, we can reasonably aim for a zero aircraft on ground objective for the next generations. And you have seen the figures also given by some of the airlines. The day you change all the maintenance system of the airline, the burden of maintenance of the airlines, there will be lots of changing in the business model when we sell an aircraft with guarantees through its life and the way it is maintained. So thinking that the predictive maintenance will not affect the way we maintain and value the maintenance of the aircraft is a complete illusion. So only that example will show you that it will be a deep transformation of industrial activities in aviation. We mentioned that. We hear a lot of that. We had to fight against it at the beginning. I prefer to keep my data. Data is oil. I will not share it, or I will put my lawyers to talk to you, and then it will last 3 years and stop every initiative. It's not the way to go. We believe that these tens of billions of inefficiencies and opportunities can be realized quickly if we work together, and they can be shared. And we have demonstrated that at scale. So sharing common data, data creates common value, as long as we are aligned on the same objective. And we have the same objective. Between airlines, airports, Airbus, OEMs, and suppliers, we want to keep the aircraft in the air, not on the ground. We want to make it work faster, better, with better comfort for the customers. So we can cross that bridge, and other industries have done it into even more aggressive manners. I could comment outside if you want. Last thing I wanted to make clear, and Anna alluded to it from the DMS point of view. We hear a lot about data science, we hear a lot about analytics, big data, and the rest. And our people sometimes are a bit lost. What's in for us? The reality is that, of course, data science doesn't create value in itself. It's a mix of the domain knowledge of our people on the shop floor, in quality, in design, in operations, mixed with the capability of data science today, whether it's technical capabilities from the machines or people, that is creating the unique value and the unique ontologies that allow to release the value. And it's only, as we said before, when you embed the business intelligence you discovered through data insight into your process that you create the value. Until then, nothing happens. So it's really this blending of these new capabilities and our original talents. Last thing to conclude, I would say that it's not on the slide, but 80% is probably about people, 20% is probably about technology, so it's really, you saw the transformation or change everywhere on the slide. It is a transformation program, it's a change of company, and it's a revolution in the industry. Thank you very much.
Thank you very much, Mark. Ellen, who has the first question? We have Björn Fern from Lieben.
Okay, so I have a question about the DDMS. To get your own data, independent data through the whole tool chain, you can either buy the tool landscape from one supplier and they provide the data format and database, or you can establish an independent own data format and database, but that's extremely difficult. It's try to do in step, for instance. So which way are you going? Is it a compromise, or can you really achieve that over the whole flow?
In fact, it's a mix. So it's really none of the two, because as you rightly explained, the two solutions have big drawbacks. In fact, what we are looking is we are working on the concept of platforms where we are combining the usual backbone tool, the one I was referring, the model and the data. And in fact, where we are working a lot is working on the interoperability. So in fact, the key focus we have is not to try to say all the tools must be similar in the same platform done by the same editors, because this will never work. But we are working really ensuring that in fact we have interoperability between the model, the data and the backbone. And it's really what we are developing and what we are working in particular with the Dassault system.
There's an add-on question.
Yeah, the reason I ask is because you said we are going to share one independent data model, which is impossible in the way you explained.
It's possible in the way I explained, because in fact we are going to capture the data independent model. I think I am not saying independent, I have single truth. That means the data is a truth and is a single reference. I think I said it's a single reference.
Okay, so
which means that
many data models.
Sorry?
But it's many data models connected.
It's connected, interoperable model.
Yeah, okay, got it.
Next question is John Ostrower here from the airport. Mike is coming.
As you bring DDMS into your supply chain, how do you work with suppliers to get them to make the required investments in their own IT systems, either at the first tier, second tier, even third tier levels, so you have that level of visibility? Are these infrastructure investments that Airbus is going to be either funding itself to help the supply chain come along, and how do you balance the requirements for those investments against the fact that you're also seeking cost reductions from them as well for all the parts that they leverage?
In fact, we are really back to the first question. In fact, there is a part where, as we did already on the 350, we are going to define what are the tools mainly for what I call the backbone. As a PLM, what tool we are going to do the design, we'll say, to ensure that there is a single flow of data that we can work, what we call in context. We import the tool as we did on 350, so we'll say nothing new. On the rest, what we are going to define is what is really tool that we need to import and what is data we need to get. So for example, if I take the industrial system, on the industrial system we are going to work at the uppermost level of the industrial system to be sure that we can model the complete system, and on this we work with the tool that we have defined at very high level. When we are going to master the way the industrial system and the production is running, in fact we capture data. So that means we are not going to impose a given tool or another one, because this will never work for a simple reason. I have been myself 6 years a supplier of Airbus, Boeing, Embraer and Bombardier. And so when you are working with different OEMs, you have an architecture which must be compatible with all these OEMs. But on the opposite, if we identify really what is the data we need to transfer from the supplier to the OEM, this is working. So really, depending on the phase of the project, when you are designing the aircraft, the industrial system will be the same tool. The more we move to execution, it will be more an exchange of data.
Can we have
a follow-up as well? As you talk about the selection of the tools and being able to, as a supplier, interoperate with whatever platform the OEM is using, as the industry has consolidated into effectively a super duopoly model, is this level of data integration only possible because of a super duopoly? If there were 7 or 8 different manufacturers that they had to serve, is the platform ultimately flexible enough to have that strategic ability to flow the data in any direction?
The answer is clearly yes, and it's what we are working on and developing. It's not because there is a duopoly, it's really the architecture and the way we want to operate, because at the end of the day, we need to ensure that we are creating value for the customer, and I said for us, but also for our partners. Because at the end of the day, if we put too many constraints and that they cannot generate value, that means we have completely missed the target. So clearly, we are taking care of the fact that it's not at all linked to any duopoly, it's something, and it's why we are looking to capture the data, in fact, with the supply base.
The tool itself, its ability to flow into any manufacturer, is there a requirement, as you guys are developing and fielding this, that actually you are either working with Airbus or Boeing and others to create a common language with which this tool spits out the data that you need to work?
Today, clearly, we are not working with all the OEMs on that, even if we look at the different OEMs, more or less everybody is working around the same type of platforms. but we are not working really on the same, on exactly the same project. Every OEM has its own project, because we are trying to develop, I will tell you, a different value. If I compare to other companies, in fact, they have tried more to optimize brick per brick, product, industrial system, etc. And really, we are sure and we are convinced that the real value is by integrating, as I have explained, the product, the industrial system, the support and the services. So in fact, we are tackling the subject in a slightly different way, even if we start from the same platform, in a slightly different way some other companies, either in the automotive industry or even in the aeronautic industry.
The next question goes to Richard Schulman.
Yeah, maybe the same question in a different phrasing. The saying goes, the chain is as strong as the weakest link. What is the weak link you see, and how long will it take you to strengthen it?
Well, just I wanted to comment on the previous question, which was exactly that point. Beyond DDMS, I think we are a very complex industry with a very deep supply chain, and we have to ensure that digital transformation is not only happening in Airbus. So we are, with different initiatives, supporting the transformation on the airline side, and we are fueling the digital transformation. We are doing the same thing at some suppliers level. DDMS will put another level onto that. I truly believe also that we will have to play, as Airbus, a role into the industry associations, because I don't believe a tier 3 or a tier 4 will have the same means to transform at the same speed. It's a wider answer to your question. Like we did in the past with air supply and other initiatives, I believe that the OEMs, if we want to bring everybody at the same speed, we will need to take some industry-wide initiatives. So, and maybe more specifically on DDMS.
Yeah, and for your point, I will say the weakest point is perhaps I will formulate differently. What is the main issue we have to face from time to time, and which can make a real impact on the way we are running our business, is in fact to discover at the last minute an issue. I will say the weakest link is more this one. The difficulty to anticipate and to have really something where we are, I will say, deep enough, it doesn't mean intrusive, but deep enough in the understanding of the full chain, if I keep the industrial process, but it's applicable for the rest, where we are able from weak signal to say, by simulation, I know that today this signal is not critical, but when I will increase my rate, when I will change, it will become critical. So in fact, it's really what we want to put in place and to generate, and it's what we are working on, and which at the end of the day will, I will say, make all the link much stronger, and which is adding value for everybody. Because for a company, a partner who have an issue, if he has to recover, I don't know, a late issue, it costs a lot. And so we are really, and it's the way we are working with this company to ensure that they have the visibility. We work together to find the best optimum and really to be in an anticipation mode. Really the target, if I have to summarize, is to avoid a weak problem and a late discovery. In fact, we focus on anticipation.
Next question goes to Jordan Chong from Australia Aviation.
Hello, thank you for taking my question. I'm just wondering, to Airbus's mind, is the question of ownership of the data a settled legal question, or have companies or airlines or other suppliers who agree to participate put that question to one side in the interests of collaboration? If you could talk a little bit about that, please.
Yeah, I think I said it. I think when you have a proper discussion, which is starting by demonstrating value, common value, you overcome that discussion pretty easily. It doesn't mean there is no legal framework and no legal protection, but it's we are moving basically to a pure IP discussion and ownership discussion to a right of use discussion. If you think about data, there are many people who have a right of use of the data. The OEM wants to use the data to improve the aircraft. And by the way, is taking commitments on the performance of the aircraft. The airlines want to use the data to optimize their operation and potentially their revenue side of the passengers. Authorities want to make sure that incidents are monitored and weak signals for safety can be captured. Airports want data for turnaround time optimization, ATC optimization. So when you think of that aerospace data, everybody has an interest and a right of use potentially, and a legitimate right of use almost from a legal point of view. And I think that's basically the transitions that we are working through now. It's not obvious, but all these initiatives are putting that question on the table, and the best way to overcome it is to immediately agree on the common value potential, and then to work it out with the legal departments.
Next question goes to John Walton, Runway Girl Network, also on your right.
Mark, I've sat through a number of these presentations, and it's been really interesting to watch the Skywise side of things evolve in particular. But we have a context now of the aviation industry sort of continually experiencing data breaches. And you appear to be moving closer towards using more and more passenger data in these systems. Have you defined the point at which the passenger data will be useful? How you're going to handle it? How you're going to certify yourself? Is there an ISO standard or something here? Or do you have to write it yourselves? At what point do you start dealing with the passenger data?
We are very lucky to leave that to our customers. No, we are not involved with passenger data, to be very clear, and all the legitimate privacy debates that goes with it. We stopped, as I said, on passenger data. For example, one of the applications we have about sensors of the aircraft is being able to feed the airlines with onboarding, deboarding, catering ready, catering not ready, seat occupied, not occupied, temperature in the cabin, and this type of thing. So it's more technical indicators about passengers and cabin more than passengers than real individual passenger data. This question is raised, of course, on the revenue side of the airline, but Skywise doesn't manage that part. As I said before, we focus on the optimization of the aircraft operation, and that can involve passengers, but at the time we have a board or deboard and their experience on the aircraft. That's where we stop.
Next question goes to...
Maybe I didn't answer fully.
Thank you. But looking at one of your slides then, you're talking about seamless experience and transparency and delays. Are you therefore just passing some data to the airline who you assume will then process the data in accordance with their own methodologies? What's the planned interface between your part of it and their part of it? Or do you just say, we will give you outputs 1 to 50 that you can then use however you like? How do the puzzle pieces fit together?
We are making, you could see the cabin, we are making the aircraft ready to have more sensors on board. So you can measure more things in the cabin according to regulation and what the airlines want to do. We stop short of exploiting this data. We are making it possible for airlines to exploit it if they want to exploit it from a technical point of view about aircraft operations. We stop short to that. Airlines are doing much more, as you know, on the revenue side, on the booking side, on the yield side. So that's their domains, and we don't intrude, and we don't compete with our customers there. They have their own solution. Sometimes there is, you're right, sometimes there is an interface, because some of the airlines want only one data platform, and since Skywise with operations is handling a lot of their technical data, they want also to host some customer data, passengers data, or finance data, or HR data. Since this is not the mission of Skywise, we create for them a private space which Airbus doesn't access, but which resolves the problem for them of having only one data platform where they can manipulate all their data, the technical data which is shared with Airbus, and the revenue data or passenger data from a booking point of view and so on, which they sometimes need to make arbitration between cancelling that flight or that flight.
We have Karen Walker from Air Transport World in the middle.
Thank you. Mark, you mentioned that you believe there'll be a need for some industry-wide initiatives as part of all of this. Can I just ask you both, can you give an example of outside of this industry, outside of airline and aerospace industry, of industries that are doing this well, doing digitalisation well, and have they taken industry-wide initiatives?
I would not have told you that 3 years ago, but I think we are not doing that bad in aerospace. I just say that because we were just in Americas last week, and we had probably 130 airlines there, and it's interesting to see the dynamics of airlines being together with suppliers, with OEMs, and talking exactly about these subjects. So, as an industry, in 2 years, I think we've gone a long way. To answer your question about, there are several examples outside of our industry, but if we take manufacturing or heavy equipment industry, and coming back to the data sharing, it's very interesting to see what happened in oil and mining industry. You will discover that in mining industry or oil industries, cutthroat competitors have created joint companies to share their own data, because they have realized that sharing their own data with the proper anonymization and obfuscation of their proprietary knowledge is creating more value for the totality of them than keeping it for themselves. Look at mining, look at oils, that's probably where you will find the most, I would say, daring initiatives. That involves a lot, that has a lot of consequences in terms of governance, of course, anonymization, and arm's length management of these data company compared to the mother companies. We are not there yet at all, but we are learning from that.
Next question goes to Steve Creedy from Airline Ratings.
No, it's on. Okay, great. As you know, everything becomes interconnected and you expand the network, you get more places, more entry points, I guess, for hackers and other bad actors. How do you ensure the overall security standard of the entire system?
You're perfectly right. I mentioned it at the beginning. Cyber is a key foundation and enabler of all this solution. A large part of this solution is also cloud-based, so you have to face not only the technical but also the legal aspect of shifting to the cloud. There is no way back. You have to tackle that challenge, and I think we are better off by embracing that challenge, which is, on one hand, putting data in a identified space, so there's a risk of putting data together in one place because it can be attractive to some people. At the same time, the technologies which have been developing with the cloud are aimed at managing more and more volume at scale and being able to automatize. So I think there is no perfect world, but you have to move also, you have to see where we are moving from. We are moving from very discrete, non-connected systems, and we know also that cyber breaches happen at the boundaries. So we are moving from a world where everybody feels is confident because we all own our data and our systems. Reality, though, is a bit more complex. If you add all these discrete systems one to each other with all these data connections and the bridges and the updates, we all know the updates, the famous updates we have to do every 2 weeks or 3 weeks on some PCs. This is creating the bridges. I am much more confident in a fully artificial intelligence managed cloud-based solution, which is looking much beyond human capability to the weak signals happening into that space. So yes, it's a challenge. The more you centralize, the more you may attract interest, but it's also, with the new tools, the way to manage at scale, the only way to manage at scale the data.
Thank you very much, Mark. This concludes our Q&A session.